All right, so we're going to move on into Unit 5, which is going to deal with the periodic table. And we'll probably spend quite a bit of time on this unit just until we get good and we understand the different types of patterns and traits and families and what the periodic table actually tells us. I really like the periodic table unit. There's a lot of information in the periodic table. Some will focus on more than others, but it's still a very interesting unit that that I really like covering in this class. All right, so you will get a copy of the periodic table for you to keep, although it is not hard for you to find a copy of the periodic table online. No, you will not have to fill out a blank periodic table, simply being because I think it's just too easy to find a copy with technology today. So there's really no point in learning it. But we will learn and try to memorize, especially these top 2 or 3 rows and some of their chemical properties, because they're the most commonly used ones, especially in living things. All right, so just some examples. Typically in class, I get you to list or provide some examples of elements, names, and then that's kind of where this slide comes from. Virtually is a little bit different. All right, so what are elements? All right, so science in general has come a very long way since the idea of elements. During the very early days of science, we're talking around the Greek scientists, that time period. Aristotle provided a theory that all things on Earth could be made from fire, air, water, and earth. Okay? And it's really not that crazy of a thought if you think about everything that each individual during that time period interacted with. It was one of those four or multiple of those four on a daily basis. So it only made sense to them to think that everything was made up of one of those. Okay? Those elements gave life, and they did understand that. So scientists have identified 90 naturally occurring elements and have created about 28 others, and that process is still happening. So that number may be a little out of date now. I haven't checked that, and I need to. But there's 90 naturally occurring elements. Some of them have to exist in some compounds in order to be stable and not radioactively decay or decay faster. But then there's some ones that are human-made, and that is still being done, like I said, as we speak, bombarding existing elements with neutrons and just to see what happens. More isotopes, and sometimes those neutrons will transform randomly into a proton, which makes a new element. Right, so elements alone or in combinations make up our bodies, our world, our sun, and in fact, everything about the universe. And this is something that y'all understand. This is not anything new, but everything is going to be made of atoms or elements in some shape, form, or fashion. All right, so the most abundant element in the Earth's crust is oxygen, right, which makes sense, and it's found in many different forms, many different compounds. And then you can go through there, you can see some of the other elements in the Earth's crust. It's quite a bit. All right, so the periodic table. All right, the periodic table is a great tool if you know how to use it. It's a table that organizes elements based off certain characteristics. Number of protons. They put them in families that they all react the same way. There's it increases by size and number of protons. Solids and liquids and metalloids and gases are all typically found together. So if we understand what we're looking at with the periodic table, based off the area that we're at, we can use previous information, to make educated guesses on which type of element is going to be what. And that's my goal as we move through this. All right, so the key to the periodic table. Elements are organized on the table according to their atomic number, which is going to be typically the number that's in the top part of the box. It can be in the top right-hand corner. Sometimes it's in the top middle. Very rarely do I see it in the top left, but I guess it is possible. So the atomic number tells us how many protons an atom has. So the number of protons, or the atomic number, is actually like it's going to be the atom or the element's kind of fingerprint. Okay? It's unique to that particular element. Once you change the number of protons, once you change the atomic number, you are then changing the element. It has a new element. Okay, it's no longer like hydrogen's never going to have an atomic number of 2. Every single hydrogen on the face of this earth and the next is going to have an atomic number of 1. Now, the atomic mass, which is this down here, it may be different based off being an isotope or not, and that's based off the number of neutrons. You can add and take away neutrons until the cows come home, and it's not going to change that atom. Okay, it may make it larger or smaller as far as mass is concerned, but it's still going to be hydrogen. But the minute a proton is added to hydrogen, it then becomes helium. Helium has an atomic number of 2 protons. It's important for you to understand that. And that is going to be a test question. And believe it or not, that is a hard concept that some of my students struggle with getting in their head. And I need you to get that in their head or your head. The atomic number is unique to that particular element. All right, so different periodic tables can include different bits of information, but typically what you're going to find again is the atomic number. You're going to find the atomic symbol. You're going to find the atomic mass. Sometimes you'll find the number of valence electrons. Typically the ones we use don't have that. Typically you're going to have the whole name of the element, and sometimes, whether it's denoted by a word or by color, you're going to know whether it's a solid, liquid, gas, or metalloid. And we'll talk about those when we get to families. And that's the end of today's presentation. Be sure you complete the video form that goes with this. And if you have any questions, let me know. Thank you.